Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Tristan Spaulding about Acceldata, a platform offering multidimensional data observability for modern data infrastructure. So, Tristan, can you start by introducing yourself?
Sure. Thanks for having me on. My name is Tristan Spaulding. I'm the head of product at Acceldata and excited to talk through data management, data observability, and everything we've got going on today.
And do you remember how you first got involved in the area of data?
Well, for me, it was very lucky and strange and coincidental where I was actually a philosophy major in college, and I happened to find probably one of the two companies that was looking for philosophy majors in the data world. And this was in the day of the semantic web, where people were building ontologies and things like that. So, let's go do some ontology with these big, Department of Defense clients and pharma companies and things like this. And that's how we get into it. And so that for me turned out to be a lot less ontology and a lot more SQL and Sparkle and R2RML was the standard, and basically just like getting pretty deep into databases and things like that. And so that was my entry point. I ended up working at Oracle with sort of the Endeca group after that acquisition. So that sort of brought me into analytics, search, big data, Hadoop, and ultimately machine learning. And then the last step for me before Acceldata was about 4.5 years at DataRobot, really, building that up and helping to grow that, learning a lot about machine learning, and ultimately building out kind of our ML ops offering. So for me, I've seen many sides of it, across the enterprise, data lifecycle, things like that. And, excited to jump into one of the messiest parts of it, I would say, which is trying to make sense of all the, innovation and all the technologies across it, which I think is one of the big, purposes of data observability as a category.
And so that brings us to where you are now with Acceldata. I'm wondering if you can describe a bit about what it is that you're building there and some of the reasons that you think it's worth spending your time and energy on.
Yeah, for sure. So Acceldata is this layer, or data observability really, I think, is this layer that's starting to emerge, where people are looking at data assets as assets and basically saying, we have observability for software, some very, sophisticated and powerful, companies and tools around that are built up. When you apply that to data, I think most people in the data world, would not feel incredibly confident about any aspect of their data in many cases. And especially when you scale it up to, beyond the one or two highlight, sort of golden assets to the wide range of assets that people are using, I think that confidence gets a bit lower. And so I think, with data observability, there's this, I think, race really, to kind of figure out how do we provide that, foundation where we can actually trust our data assets as much as, for example, we trust the homepage of our website. Just to pick an example where, you would not deploy that without extensive monitoring and change cycle and things like that, change review cycle, code review cycle, in many cases. So why would you do that for some of the data that's powering not just your reports, but the products and services that you have? So, I think ultimately it's about bringing reliability to something that's increasingly important as an asset, which is basically your data pipelines. For Acceldata, I think Acceldata has a quite unique angle on this. So, the mini, background story on Acceldata is really the core founding team came out of the Hortonworks engineering and data engineering group. So this was a group that was deep in the middle of some of the most innovative technologies and basically big data projects of the era there. So I think it's the group that's deeply familiar with both the operational challenges of actually running these projects with the organizational, sort of goals and problems and structures that are around them, and with the actual data problems on top of it. So I think it's something where, everyone, I think, sees this opportunity. It's like, wow, this data is important. We don't trust data. How do we solve it? I think for me, when I was sort of still fresh enough to sort of understand, thinking about the options and the market and things like that, what stood out to me with Acceldata is really what we would call the multidimensional aspect. So going very deep, not only into the data itself, but actually into the systems, powering that data. So for example, if you have a data pipeline you've written in Python here and it's using Databricks extensively and you get an alert, hey, this pipeline's slow. Well, I think one thing to do is kind of look at the data and what's happening with that. The other thing is to actually dig in and try to resolve the problem and figure out, how do we tune this? How could this run more effectively? And I think that's something, doing those together, like I think there's very few people that are able to really deeply understand, data distribution and drift and anomalies and things that way, and set up the controls for that and understand that should be setting aside the actual domain expertise of the data, which is a whole other aspect that's quite critical, and actually go into the various technologies they're using to actually process the data. And so with Acceldata, I've seen, the ambition to kind of tackle both sides of that, which is very, very difficult to do. I think precisely because it's difficult to do, I think it's something that there's going to be some really interesting opportunities and great product opportunities.
So when I introduced the topic of conversation for today, there was quite a mouthful that I actually pulled from your website about multidimensional data observability for modern data infrastructure. So there are a few different things to unpack there. And data observability, you touched on that a bit. I've done some other shows about that. The modern data platform, modern data infrastructure, that's another area that I've spent a decent amount of time on, where it's, this reorientation of the data warehouse as the focal point of all data operations and data analytics. But multidimensional is something that I'm definitely interested in digging into and getting your sense of what that means for a data observability platform to be multidimensional and some of the ways that that manifests.
Yeah, well, I think part of it actually comes back, to the distinction people sometimes draw between monitoring and observability, like setting aside data and things like this. I think people sometimes, there have been monitoring tools, and now people contrast themselves as saying, well, we don't just provide monitoring, which is kind of telling you what's going on and giving you that signal. We provide observability, which is basically understanding how you can map, external behavior and signals that you're seeing to internal, operations of the system and applications that you maintain so that you can actually fix them. And so I think for whatever reason at this point, I don't know that data monitoring, sort of like there wasn't an era of data monitoring, I think, that I'm aware of where that came out, where people were really intense on that. I think people went very quickly for the term data observability. For whatever reason, I think it sounds cool. Like people do ML observability, like everything's observability now in name. I think, when we say multidimensional, we're trying to kind of, I think, double down on basically, hey, we're going to let you understand up and down, left and right, basically how these things relate to each other. Like, we're not going to be content to just tell you, something very useful, by the way, which is like, hey, like your data is bad quality, like it's late, things like that. What we want to do is basically say, hey, what happened here was that, your data drifted and that caused your Spark configuration to be suboptimal, which caused us to take longer, which meant the data wasn't there, which meant the join you had downstream, like was joining on old data, which means your results are bad. Like, there's a big difference in taking an individual user through that entire kind of journey, which mixes a ton of technologies potentially, in a ton of angles, and kind of just doing something, again, useful, which is telling you, hey, something's gone wrong here. So I think multidimensional, it'd be better if we could say, hey, like these things are data monitoring and we're data observability, because we go deeper and we tell you why and we help you fix it. I think multidimensional is just a way to remind people like, hey, there's more, that the life of a data engineer these days is a quite complicated one and requires dealing, with multiple aspects here. So I think that's what that gets at, I would say.
Digging into the modern data infrastructure aspect of it, you touched on this a little bit with the variety of systems that you might need to jump across to be able to actually diagnose the true cause and effect of an error. But what are some of the requirements and implementation details that are brought in as a necessity because of the fact that we do have this modern data stack and modern data infrastructure where we will likely have a variety of different components of tooling and different vendors and different concerns that we need to be able to traverse while understanding the entire life cycle of a data asset.
Yeah, I mean, I think the diversity is one of the big aspects of this. I mean, as things have, moved from, I think we get sort of one drag and drop tool from a big, vendor, and it kind of, we use their databases, we use their BI tools and things like that, into this world now where we're writing code, like we're using the best of breed, where there's a new library every week, that does something super powerful that takes off. Like, the first requirement, I guess, is basically, it sounds simple enough to state, but like, is to have eyes on all of that. And so be able to actually instrument, data pipelines, code-based data pipelines in a meaningful way. I think this is where, some of the existing tools, I think, get a little lost, because like, you can have great analysis, but if you're only analyzing 5% of the actual assets that are out there, and importantly, not the ones that are actually maybe the newer applications, the ones that are tackling new revenue generating initiatives, like, there's a limit to what you can do there. So I think the first aspect is basically breadth, of integrations and able to actually meet the workflow of a data engineer. I think the other interesting aspect with this is kind of the difference between, data warehouses and data pipelines, I guess. And what I mean by that is basically, like, obviously BI is a very well established use case, and the data warehouse has a lot of uses. Like, that's not going away. But what's changing, I think, is people are dealing more with raw data earlier. So data isn't necessarily born in a data warehouse. Like, there's something emitting it. There might be a stream taking it in, but like, it might be a file sitting somewhere that then you're going to process, and ultimately you're going to load that somewhere else into a different database. And the great thing today is you can use the best of breed for that. Like, from an operational standpoint, it's a good thing to be able, or I should say performance standpoint, it's a good thing to be able to, use the best tool for this. But from a complexity point of view, it's not a great thing. And so I think one of the big aspects of data observability is to look at, where you're looking at this, like, basically at the point where it initiates and where it starts in a file. We're looking at the point where it ultimately ends up in the data warehouse, and, we run reports off of it. And now we want to know if those reports are good or bad. And like, can I trace back this thing in the UI to that? Like, that's super valuable, like, use case, but it is like a limited segment of what I would say the modern data engineer looks at. And so I think, sometimes I think we use the phrase like shift left. We borrow the phrase shift left from DevOps and things like this to kind of say like, hey, if you're drawing the diagram of the life cycle of data, like, shift your observability and your monitoring left to the point where the data actually originates. And that's actually like quite difficult to do. That's a quite difficult technical problem, because one, that data is raw, two, it's not necessarily, indexed for a query. Like, you can't write SQL against that necessarily. That's going to capture it. So even expressing the types of thing you're looking at are harder. And I think the other aspect is it's going to jump across three different things along the way. It might jump from streaming system to, Databricks, and ultimately end up in a, data warehouse somewhere. So I think those are some of the key technical aspects. Like, it's quite challenging to do like across the whole lifespan. And so I think personally for me, like, that was quite interesting about Acceldata. It was like, wow, like this is a harder problem than I thought. There wasn't an out of the box like solution to do this. And like, there still isn't an out of box solution. Like, Acceldata can do it with all these things, but it's not a simple task. And certainly one of the directions, the reason I joined the company is to help us, make this into something that's incredibly powerful and easy to use that covers all of it. But it's a big challenge to do it all, with the real complexity of the modern data stack.
One of the continued pieces of feedback that I get when I talk to people about the complexities that are inherent to the space of working in data is the fact that there are so many different stakeholders with different perspectives and different priorities and different backgrounds in terms of their technological depth or focus. And I'm wondering what you view as the kind of core personas for Acceldata and how that influences the areas of focus in terms of feature development and user experience design and just your overall approach to priorities and how you think about collaborating across all these different stakeholders throughout the life cycle of data.
It's interesting. And I think we've kind of taken a bifurcated approach, I would say. So it really starts with a data engineer and saying like, you want to be a high performing data engineer. You want to be building these pipelines. You want to be tackling new use cases, and you want to be doing it better, faster, more reliably than anyone else. And so how can we basically, on the one hand, help you achieve that goal, and on the other hand, not give you too much extra work? So if we're going to say like, hey, guess what? We'll give you that stuff, but first you need to write, 100 lines of code to set up, basically tests on every component of this. And by the way, you need to learn what population stability index is and like how to compute anomalies. Like that would be a bad user experience that would lead potentially to a good result. So I think, just saying like, all right, we want you to get to reliability, but we don't want you to do, have to change your workflow that much, I think is one guiding goal for us. That's, again, like kind of easy to state, but very hard to pull off. And this is very much something that, I thought about quite a lot at Data Robot, where it's very much around, hey, for data scientists, like how are we going to take some aspects of your job and basically automate that in a great way, or even like superhuman way. And so, it's a lofty goal to hit, but I think there's an aspect of that level of automation and meeting the data engineer where they are today that we have. I would say the other approach, that the secret master plan, of course, is like, there's another persona that's really missing a view on what's happening today. And that's basically the CDO and the data executive who is charged, ultimately with making some really smart choices on where they invest across different tools. Like these budgets are, spend is going way up on a lot of these things, how you navigate across, cloud migrations, things like that. And so I think one of the things we try to do is say, as we make it easy for data engineers to kind of understand, to make their pipelines more robust and monitored and respond to incidents faster, we're also building up a map of how data and basically how data technologies are being used across an organization. And that map can be very helpful for really every sort of manager, up the chain in the data executive sort of like flow, because it lets you know, not just, on paper, what's the relationship between the systems, or on paper, which things are good, but in reality, who is using what technology? Is that data actually any good? What did we spend on that? What do we spend on that relative to how much our data is growing? Things like that, and ultimately map that into revenue. So I think, it's a long-term thing here, basically to say, you build up, make it easy for, individual data engineers to kind of achieve their goals. And in the meantime, kind of inform the broader organization, which technologies should we invest in? How should we adjust our spend? Especially with, I feel like sometimes, I don't want to even mention the word data mesh, because it can be used lots of different ways. But like, I feel like sometimes that's used in a way where it means, hey, different teams are kind of building up and managing their own, not infrastructure, but managing their own cloud services that they're buying. And so you need a map of that, and you need sort of guidance on how to control and manage that. And I think, it starts with understanding what data engineers are doing and then helping them with the aspects they need help with, and then bubbling that up all the way. Like one of the big distinctions we draw that does help clarify things for us is like we view, like along the lines of this sort of the shift left, comment or philosophy I mentioned earlier, like we view like the ability to write code and use APIs and add customization and scale things up as basically like a good thing for us. Like we view that as like our users view it as a good thing. So like that's a nice division for us in certain ways where it's like, look, if we want to do, point and click kind of data quality policy creation and review on data warehouse data, like, or do sort of data steward type actions where we're trying to understand, and govern data, like those are super valuable traits, but they're also things where we say like, that's a great thing for us to partner, to work with our partner on. Like, that's not really our focus. Our focus is like, you are a data engineer, in many cases you're writing code, you're writing Python, Java, Scala, you're using these technologies like, and you're solving these complex problems on pretty raw data. Like that's the type of persona and data engineer that we really, have success with, I would say.
And given the very deep and detailed and technical nature of the product that you are working with and your focus on helping customers be able to understand the value and helping to understand what direction to take the work that you're doing, I'm curious how you have approached that as head of product, where you need to have this understanding of the underlying fundamentals of what it is that you're doing and how it's operating, but you also need to be able to work at the level of the customer and just being able to thread that needle given the kind of complexities of the space.
So I think generally it's a good signal for basically a product managers and product leaders and things like that to be, confronting an area where there's a ton of technical depth and challenges going on. Because I think that means that as you're able to, work with your team and like all across the board, including UX designers, product designers, all of this, as well as the hardcore engineers, like once you're able to come in and understand that and put that into something that's easy to use, like you've added value, for the customer. Now someone who didn't understand how to tune a Databricks job, can do it very quickly in 1 or 2 clicks. Like, it's not where we are today. Like what we have now still requires, thinking through, but we've captured the signals and we have ideas basically in data on how to improve, and to give these suggestions. So I think, at one level, it's, we're trying to build something has superhuman knowledge embedded in it, in the sense that, no one is going to be an expert in all 20 of the technologies, that you might look at. Like even within streaming systems, like there's you could rattle off 25 streaming systems that are out there that people may be using, that all are tuned and optimized in their own way and have their own concepts. So as we try to embed all of those in the product, that's going to be something that no individual, certainly not me, is going to understand the details of that. But I think it's a good signal. And so the question is basically always to keep coming back to, what's the outcome that we're driving with this? What are we noticing, when something goes wrong? What are the ways it could have gone wrong? Now let's drill into the specific metrics and kind of line those up together. So it's an interesting, design challenge, basically, and product challenge to think through how you prioritize this and how you set up the hierarchy to drill through. I don't know if that's what you meant by, dealing with a technical topic, but I think that is, one of the things that we do a lot.
Yeah, it's just always interesting to get some perspective on the different roles and responsibilities that are required to be able to build these different data products. And so just curious, given your view as somebody who's leading product direction and still needs to be able to understand all of these technical details, how you approach your particular job.
Yeah, I mean, it's a lot of asking questions and a lot of learning. I think that's one of the fun parts really is you get by being one of these companies where you're taking on this type of challenge, you basically heard by osmosis picking up some quite useful things. So I would say, just as an example, just since I've joined, Acceldata, I've learned so much about Snowflake and, and even Snowflake in its time has evolved in terms of the capabilities that it's offered for, how to track usage and how to optimize things and things like that. And I think that'll continue. So, it's a lot of learning from this. And then, winding it back to basically what are we trying to accomplish on this? It's well, people don't want to be spending too much on their Snowflake instances, but, get some surprise bill. I think many people have been burned by whichever cloud provider, it's not a Snowflake specific thing. So how does this tool do that? And by the way, it also helps where we have engineers that are incredibly deep on Snowflake and understand it, and same for other data platforms. It helps to have someone like me that's coming in and asking questions. I don't understand what that is. How would we do that? And then helps bring it to a place that we're making sure the value comes clear, or the key, metric you need to get value comes clear. So always a work in progress and always something we refine. That's why you want to have great engineers in your company.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. In terms of the specifics of what you're building at Accel, can you give a bit of an overview about how the platform is implemented and some of the architectural elements and the specific sort of technical challenges that you faced in being able to service such a complex space?
One of the interesting things about data observability specifically is that it has a huge amount of operational concerns embedded within it. And so what I mean by that is that data sets that people are dealing with, you could have 20 gigabytes that you're, building a dashboard on and it's updated once a month, or you could have 4 terabytes coming in because you're getting let's say gaming data, sent in, and that's 4 terabytes per day for your data engineering team. You need to deal with that. So those are huge differences in the volume and velocity of data that you're dealing with. And so it's a little bit, it's unlikely that the same technical solution is going to be optimal for both. There might be one that's more convenient. There might be one that's more powerful. And then you have to think about what some of these things, when you start, how is it going to scale up? So I think one of the big, architectural choices that has given Acceldata, the opportunity to service some of these, huge use cases is basically the decision to use Spark, basically as the underlying, processing engine. So in some cases, you'll find tools are doing things in database, which has its own advantages. You can write SQL, that's good. That's a little bit cleaner and things like that. And that can be good. Excel has taken a different choice, basically, where typically we're not running in database. We're actually running our profiling and our analysis and our aggregation in Spark alongside that. And so that's given us a number of advantages in terms of a few things. One is obviously cost price performance. So if you're running in DB and your database charges by usage, then the total cost of ownership is just going to be a factor. That's still going to burn in a little bit there. And so as you go from like basically, early scale or one use case, BI use case to like, oh damn, like now, now I'm, processing tons of data here and I need to scale up all that stuff. Like that curve might get a little bit steep for some people's taste, especially with some of the, cloud data warehouses today that people may or may not be as experienced at tuning. I would say the other like important aspect with this is taking load off of the database. So the last thing you want to do when you're trying to say like we're optimizing our data pipelines is actually put a lot of load on those data pipelines by running queries at precisely the same time that you're doing your workload, right? You've got your normal workload that you're trying to make sure is good, and then you've got your monitoring workload. And if those are running on the same system at the same time, a quite intense monitoring workload is going to interfere with your actual workload you're trying to protect, which is really the last thing you want to do. So that's something we've taken pains to avoid because we want to do a very intense, analysis of the workflow while it's happening and have that happen quickly. Then I would say the last bit that's important, ties back to what I mentioned earlier around basically the expressiveness of what you're able to do. So when you're, for us, we are trying to handle very complex use cases, like we're skewing towards that side, and we expect and encourage people to basically write code and write custom rules, custom Scala expressions, complex multi-table sort of analyses, multi-data source analysis, like when you're doing this, like just to ensure data is. So there's a number of use cases for that we have customers using. Those things are like really not very straightforward to do or possible to do in many cases, like if you're just like living in a relational database, but they are very possible to do in Spark. So this is another aspect where basically, price performance, as you scale up to really high volumes, avoiding stressing your operational workloads with your monitoring workload, and then the expressiveness, like those are all key elements of Spark. I would say, the other big technical choice, that's there, technical challenge, which I think is common across many companies, in the data world now, is basically, your cloud architecture. Like, how are you going to do this in a way that's basically going to be efficient and not move lots of data and also be sensitive of privacy considerations? So are you going to move everyone's data in and then you'll analyze it? Like, are you going to, push that down to the databases? Like, how do you manage that? And so this is something that we actually have a lot of like, in VPC deployments and sort of like, fully hosted by the customer environments, things like that avoid that. That's one not easy to support option, but one that, we have a lot of. And then, there's also, we'll be launching sort of a cloud service that has a hybrid deployment model in the coming months here as well. So I don't know if that kind of answers it. Like that is like, I would say the number one like dimension on this that we've chosen is basically use open source. It's not just Spark, like, we use Kafka, so like we scale like a lot on this, but we've chosen not to use like the more proprietary technologies as the underlying part of our stack.
In the evolution of the product and the project, I'm curious how the design and goals of the system have changed since it first began and since you became involved with it.
Yeah, so I think a lot of the origin of the company, had to do really with understanding deeply, the data processing technologies, whether that's, sort of Kafka or, Hive or Snowflake or Databricks, things like that. Like it was quite deep on that area and able to serve those things up. I think there was very much also a way to kind of connect, some of the data profiling, I would say, aspects to across there. And so I would say the big thing that I've been focused on, in the time that I've been here is basically bringing these sides together. I think is one big aspect and making sure, the crossover between these is incredibly clean so that when you do have an incident on one side, you're able to understand not just like, hey, this data's late, like, sorry, go ping IT, but like, here's what was happening with the database this was using at that time. That's been an interesting development here of like bringing these aspects together, which has both technical implications of how you sort of set up the various agents for this, as well as significant sort of user experience things there. I would say the other aspect, like I bring a little different, like I've been working much more on the last stage of the cycle, the data life cycle, I guess, where, you've got this clean data, these clean data pipelines that work perfectly. And now you're building and running machine learning models on top of it. So there's a lens that comes to that. Like some of the things you look at when you're powering that type of use case are a little different from things that traditionally we think of as like data quality or data reliability, things like that. There's a little more focus on things like data drift, basically like how data is changing over time. And is that expected? Is it unexpected? Is it a real change in the world or is it a problem? And how do you attribute that? and how do you actually get to the root cause of which thing is performing, more or less well or reliably. So I think, one of the things I started to bring a little bit, and I think we'll start to see show up in the offering quite a bit more, is basically, enhancing kind of the embedded smarts of the product. Like how much of this sort of machine learning aspect is it doing for you, both in terms of actual embedded machine learning and embedded best practices. So I think, that becomes an exciting area to look at for a couple of reasons. Like I think one is, obviously we're in the business of trying to make this easy for users here, and definitely using data to inform that is one way. But in the bigger picture, I think there's still, and there will continue to be an evolution in kind of how the roles of data engineers, ML engineers, data scientists, ML ops engineers, data ops engineers, data reliability, like all of these roles, like those job titles exist, and the responsibilities, it's not clear, it's solidified who's going to do what. My view, having seen a lot of, sophisticated ML organizations, things like this, my view is that, in many cases, data engineers have a primary role to play basically in serving any data that's going to the outside world and controlling that. And so today, I think a lot of that tends to be a little gated, and it's like, well, you need to be data scientists, like you need to understand, these metrics and the life cycle and things like that. I think it's possible, like with the right tool and the right sort of things built in, like it's possible for data engineers to catch that stuff and manage it, much earlier in the life cycle. And I think, data engineers have a lot on their plate already, but they are the right people with the right controls and the right knowledge and basically the right mindset to be able to play a bigger role in some of these. And so I think that's something that, I don't know if that's a consensus view now, but I think that's starting to be something that we're exploring, is how much can we make that happen? And, what effects will that have in terms of unlocking some of these use cases beyond data warehousing?
And as far as the actual adoption and usage and workflow of Acceldata, what are the steps from saying, okay, I need to be able to understand at a deeper level what's happening in my data platform and my organization's data ecosystem, and then actually installing and integrating Acceldata and being able to use it to start being able to figure out what are the actual pieces of information that I need to be able to do my job better, improve my operations, improve my reliability?
So I think there's, organizational aspects as well for any sort of data project, where you're trying to prioritize like which are the things that are actually going to be important to look at and that are going to benefit from this. I think in terms of the product itself, really to the extent possible, we try to automate this stuff so that basically by installing agents that we have, we're able to collect the data, analyze it, and basically, suggest rules, identify patterns, and basically set those up. So it becomes a matter of basically reviewing these suggestions to kind of say, okay, are these patterns of usage plausible? Like, this is saying, I don't need this much capacity. Should I turn that down? Oh, it's saying the data is bad in these ways. Is that true? Or, do I want to dismiss that? Or do I want to add extra coverage? So I think those are the main aspects for it with this. I would say that's when you're going directly to the data sets and data platforms themselves, like you're going directly to Snowflake or directly to Databricks or Kafka, whatever it might be. I think there's a little bit different adoption path for data pipelines themselves. So in that case, there's a step of instrumentation. So basically going into the Python, code that you're orchestrating with Airflow and basically adding a few lines, identifying, hey, this operation is starting now or is doing this. This chunk is referring to this. And one of the things that lets us do is basically then build, even though your pipeline was built in code, it wasn't built graphically, you get a visual representation of that with sort of things, lit up and indicating, the quality across those. So I think that's a little different angle. And certainly that one, as well as something that's, we're trying to refine and make that as simple as possible, and recognize things, there's a lot to do on that. But those are basically the three paths. It's like install an agent, similar to APM tools and things like install kind of an agent to collect this information, review what's happening. And then for the data pipelines, add a bit of code in order to keep track of what's happening here.
In terms of the tracking of events in a data platform, being able to pull out the useful metrics, I'm curious how you've approached the design and structuring of those events and being able to correlate them across the disparate systems that are needed to be able to understand what the actual transformations and usages of these data assets are, particularly as you move into things like machine learning training systems and being able to say, okay, well, there's concept drift in this model because of the changes in the data schema that were introduced at this application database, and being able to traverse that whole graph of operations and transformations and usage.
Yeah, well, I think there's a couple of senses of correlate that are important here. Like one is basically like once you have the map of what's there and you understand, this is what the data pipeline looks like, you can always look upstream and say, okay, what was the data set that went into this Databricks job? And you can go deeper into that and say, oh, this had, drift in these columns, and like I didn't expect that. So now that's why this job took longer, which is why these other things are late, which is why this happened. So part of it is having the map, and that's sort of like the human sense of correlation that lets you do this. And being able to flip and back and forth kind of between these lenses so you can actually understand, what happened in each one and what effects that could have downstream. I think in sort of the, statistical sense of correlation, like, ultimately many things in data world like are time series. And so like if you have a sequence of time series of metrics, like, or rather thousands of them emitted by all of the systems that you're using, and you also have a time series of data in terms of like what are the values at a particular moment, or certain aggregates of what was the standard deviation at this moment or whatever, like picking random examples. But like you can build time series of each of these. And so once you have a time series, with a value, and a timestamp at each time, there's many things you can do, on top of that to basically, cluster those or compare them or find similar ones, or detect what's anomalous at the same time as something else, things like that. So decompose them and see which are trending together. So I think this is one of the ways that we think about it, and why we're excited about kind of being able to capture both sides together, because we do have both sides together. So I think being able to see what spikes at the same time and what spikes before something else, and then as you do that across multiple use cases and multiple systems, that starts to become a really exciting capability. There are examples. I don't think anyone, in the APM world has taken it like to that fullest extent yet. Maybe they have, but certainly there are parallels from, pretty mature companies, like New Relic and so on, that do some type of this time series analysis that we can learn from in the data world. I just think the data world can be a little more like, because we like live in data, like we can be a little more advanced about that. And there's things you can generalize across data sets that you can't generalize across, applications. That gives us another tool for kind of finding ways to connect these. But I mean, the fact is just like things were already incredibly complex for data engineers, like before there started to be this explosion of tools, and like it's only going to get more so. And so, we think there's value to add in being able to, actually connect these pieces and line them up.
In addition to the sort of data observability aspect, one of the other pieces that you have in the Acceldata platform is being able to do performance monitoring of the compute that is necessary to be able to do these data manipulations. And I'm interested in digging into some of the ways that performance data that you're able to collect can feed back into optimizations and debugging and maintenance of the data pipelines and data transformations that are necessary to be able to actually derive value from the raw information that we store.
I have to correct you though, because like, do you distinguish data observability from, visibility into the compute of the actual data systems underneath? I think that's the distinction we're trying to, basically trying to reject with saying multidimensional. Like, I think we would consider like, yes, if you're relying on a relational database, to power your dashboard, and something's just going from your database to your dashboard, like maybe you don't need to know that. You just trust someone to handle it, things like that. I think when you're doing complex data pipelines, like there's not an ability really to distinguish between these. So I'll try to give a couple of examples. Like what I would say is like, we actually do have a product tour up on our site now that kind of walks you through exactly this scenario, in the example of a Databricks job, basically saying, I won't spoil the story more than I already have of what happens, but basically, takes you through the experience of finding out what really caused, a pipeline to be late. So I'll try to avoid that one. I think, a good example of this is basically like one is around basically capacity and compute volume. So, one of the challenges today is as people are adopting these sort of like pay as you go, data platforms, things like that, is basically there's a capacity problem. So, and so you might have quotas on it, you might run out of space, you might rack up suppose. And so one of the things that can drive excessive usage is basically, bad queries and bad joins. So that's something, if you have data that's coming in and you have duplicate rows and you end up having a join, that should be one-to-one and it ends up being, many-to-many, that's something that can multiply and explode, basically your processing time and your compute costs. And so I think if you're coming in basically from the perspective of someone who's like, what is going on with my Snowflake, my Snowflake bill, or like, if I'm in a data mesh team or whatever, I'm responsible for this service, like, why am I, hitting my cap and I'm not processing that? Well, the root cause isn't that something, like Snowflake did something wrong or these things broke. Like these things are pretty solid. What happened was the data was actually bad that went into it, or the query was bad that went into it. And that's actually what caused the problem. So I think that's an example of basically how these things intertwine, where either your cost or basically your time to process can be blown up by this stuff. The other one that comes to mind on this that we see is basically, the aggregate load on the system. So if you've got, 100 data pipelines going, which is probably an underestimate for most companies these days. If you've got 100 data pipelines going and you're looking at them and you're like, why is it slow? Why is it late? That's a property of you're looking at my data set isn't where it should be. And so you might look into like, okay, what's the data? Like, what's wrong? Do we not get the data? Like, is this taking too long? Was the data bad? And the reality might be actually, no, like it's not bad. It's just the underlying system was impaired that was processing it because it had too many things, on it at one time. And that's ultimately the cause of this. And I think you would not necessarily be able to perceive even something as simple as that unless you actually have some insight to that. So if you're looking at that at the logical layer, the data layer, and you don't have much ability to zoom in on the actual data processing platform, you can say, hey, like IT, data team, data platform team, go look into this. But the real cause was quite evident if you just had a lens into that and could join it up. So I think those are some of the more, prosaic, examples of basically how the root cause of these things may not be super deep, but it is a level deeper than just looking at the data sets flowing through the system.
In order to gain value from a system such as Acceldata, it's necessary to be able to view and understand and interpret the information that it's presenting and being able to generate alerts without having too many of them and being subjected to alert fatigue. And I'm curious how you've approached the design of the platform to allow for this interpretability and being able to maintain a healthy balance of visibility and obfuscation of sort of what is useful information and what's not.
Yeah, I mean, alert fatigue, we heard an example of someone who was just getting 7 pages of alerts per day on the stuff. And they're just like, this is useless. I'd rather have not an Acceldata customer, of course, but they're coming in, and saying, this is not useful. I need something, that's actually going to prioritize and put these in. I think there's a part of this that can be kind of, automated and done with software, and a part that is just basically human input. And so we kind of adopt both. So one is we make it pretty straightforward to basically go in and prioritize, assets and columns and things like this, in order to say this one, really matters. This one matters less. I would say there's also an ability to come in and you want to get that by proxy. So if you go in and you're able to analyze the query logs or the usage of things, I think that becomes another tool in the toolbox to say okay, this table is being queried a lot. Maybe I should really care about the quality of it. And that's something you can do more or less, automatically if you've got the right signals. I would say actually the compute aspect, this is another aspect where having the 2 layers together is actually quite useful because yes, there are some systems that allow you to parse query logs and analyze that and see what's being used. Some systems do not let you do that. And so you might use basically the cost, how much data it's processing, as kind of a cue for the importance of this pipeline. So I think that's another element that gives you a bit of a signal on top of it. I think ultimately, the dream for everyone, it's in a race to who can do it, is basically very data informed, thing, and a data informed process where, you're sifting through all of this, you're ranking everything, you're, having people give feedback. Hey, is this useful? Is this not useful? My read is many organizations are not at the stage where there's actually data to do that as effectively as you'd want to. I mean, maybe other people disagree. I think it's an awesome feature and it's an impressive demo and things like that. I don't know that that's the stage that we're at in terms of usage to actually let you do real, recommendation on top of it. So I think we try to capture the signals we can, give people a nice alerting framework that lets them rank it, kind of build from there. Yeah, I mean, I think that's basically what it is in terms of alerting. I would say the other big aspect, it ties back to one of the persona questions, is like we also like look a fair bit at reporting too. So like there may be people that are not looking for alerts and 7 pages of alerts or things like that. I don't think anyone's looking for that, but they might not be looking for any alerts. But what they might really be looking for is basically the report on how is my spend on data technologies trending? Like, are we actually using that wisely? Like, I just spent $5 million on this data warehouse. Like, why did I burn through that budget in 2 months instead of 6 months? Like those types of reporting and insights, are quite valuable. And so we also look at, basically how do we bundle these up, give you a dashboard, let you export it, all of those fun things to help reach other people in the audience who might not be like the day-to-day users.
Timescale DB from your friends at Timescale is the leading open source relational database with support for time series data. Time series data is time-stamped so you can measure how a system is changing. Time series data is relentless and requires a database like Timescale DB with speed and petabyte scale. Understand the past, monitor the present, and predict the future. That's Timescale. Visit them today at dataengineeringpodcast.com/timescale. In the operation of Acceldata, I'm sure that there is a substantial amount of information and reporting and your own data transformations that you're dealing with. And I'm curious how you are kind of dogfooding the platform to help build the platform.
If this was like a CRM system or something like that, or a dashboarding system or something like that, we would absolutely do that. I would say Acceldata, 3.5-year-old company that does not necessarily have the data volumes, or the structured use cases that would support that type of investment. So it'd be good to do it, in some ways, but the use cases where it starts to be valuable, become valuable when you're a big company. So we're not a big company yet. We serve very large companies. As much as it's a good practice to dog food and stuff like this, it would be a little bit, synthetic for us right now. So we obviously are exhaustively testing it and using it every day and things like that and banging on it and finding all these problems, and fixing them. But yeah, I don't know that there's a huge match actually between our needs as a 3.5-year-old startup and kind of the, gigantic, multi-billion-dollar global 2000, companies that we sell to.
In your experience of working with Acceldata and helping your customers and understanding the product to help drive its direction, what are some of the most interesting or innovative or unexpected ways that you've seen Acceldata applied?
So the ones that have been striking to me the most are around actually monetization of data. I think many people are familiar with BI and data warehousing. I was also very familiar with basically ML-based use cases. One thing I was not as, conscious of basically was data marketplaces and companies that make their business off of exposing their data or basically selling analysis on top of it. I think as I've been here, I've looked into this more and I've seen some stat where I think 75% of, big companies or something like that are basically consumers of assets from data marketplaces. And it's probably 25%. And then the projection was that it was going to be 35%, in a couple of years are basically contributing and monetizing through it. So I was a little bit surprised, some of the complexity that goes into some of these things where you're selling, basically exposing data as an asset that you run your business off of. And so this has a much wider and different set of requirements than I had seen. And that's something that's kind of, broadened my understanding of what people are doing in the data world and also what products need to do to match that. So just as an example, if you've got a data set that you're monetizing around, worldwide business activity, you might be pulling data from 100 countries around the world about the businesses in there. It's going to be a worldwide thing. There's going to be huge concerns about how do you compare, these files that are coming from different groups and actually standardize them against a canonical database. And they are coming as files. It's not the technology was not super centralized, things like that. So, I think that's an example of something where, getting that wrong or being able to get that to a certain level of quality in a certain amount of time has a real tangible value to a business because they're literally selling their data. And when it's bad, they're not going to get a complaint from the VP that the number was wrong or I don't believe that number. It's going to be I'm going to go to your competitor because your data sucks. So I think that was a little bit, new for me. And then I think I mentioned earlier, for me, seeing the richness and kind of the complexity of these and basically the speed of evolution of these, data processing platforms, whether it's databases or other ways of processing data, it's been really interesting to see how those grow and how those scale. It's an awesome area of technological innovation these days. And so kind of just a lucky perk of Acceldata for me is being able to learn about some of those from some people that are using them, in anger and some technical experts on our side.
In your own experience of working at Acceldata and helping to explore this problem of observability and monitoring and correction of data systems, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
One aspect that's overwhelmed me even has been really trying to understand every tool in the offering in the space today. So I think you look at this stuff and like if you're focused on a certain area, you are like, wow, there's a lot of cloud data warehouses, or like, wow, there's a lot of pipeline orchestration systems, or there's a lot of ML serving tools. And like once you're in that area, you're blown away by what's coming out. But then with observability, when you're really trying to have a view across the evolution in each of these areas, like it's crazy. Like it's just trying to understand the distinctions between all of these data catalogs, data governance, like data pipelines. Like what are these things and how do they relate to each other? I think was definitely eye-opening for me, as well as the pace of these things. So if you go into these and you look at the rate of growth for some of these tools and technologies, like open source or not, like it's just incredible. Like the cycles that, might have taken, 8 years, 10 years in the past for something to kind of reach a critical mass from when it started. Like now those are like 8 to 10 months or something for some of these projects that are just exploding. And so I think, it's fun to keep track of all these things, but, it stretches your mind a little bit on this. I would say another thing that's kind of been an interesting, lesson or interesting study is basically like how the roles are changing for data practitioners. And it's related to this, like where you find people and like some people I think are, if they're focused on BI and analytics and things like this, they're looking at, DBT and they're looking at like Firebolt and like all this crazy stuff. That's like awesome stuff and all these different ways of doing it. But like there are other people that are looking at completely different tools and kind of have the same feeling that may not be equally looking at it. So I think it's been interesting to see, kind of the balance there or the shifting balance of how people are kind of self-selecting into certain use cases or certain technology stacks. And others like data observability, kind of forces you to look at all of these together and not really, have a stance on, hey, this is the one, this is the other one. And I think we'll see in the data observability market, like probably people will arguably already have kind of segmented themselves a little bit towards particular use cases or particular personas. But, in studying where we are and where we fit, like you see a lot of diversity in how people are splitting each other up. So,
and for people who are trying to get better visibility into the operations and challenges in their data platform, what are the cases where Acceldata is the wrong choice and they might be better suited with a different vendor or a set of open source tools or building their own internal capacity for these debugging capabilities?
I think part of the question to ask basically is around like basically the type of use cases. Like that's what I would start with. And also you can look at the type of people you're trying to hire for your initiatives. So like, I guess what I mean by that is like, there are absolutely super valuable use cases, like where people are running ERP systems and they're focused on reporting and BI use cases and things like that, where, there's a very mature tool set for that. And like, I think those cases are well covered. So if someone's looking for like, how do I make, the quality better on these dashboards? Like, yes, Acceldata can do that, but that's maybe not what data observability, at least in our view, like is really for. I think, when people are looking at, wow, I'm using a mix of technologies, like I'm moving between, an on-premise environment and a cloud environment, or using multiple clouds. Like, I think that's one kind of cue. I think when people are saying, like, I'm not just a reporting center and sort of a cost center and things like this, which is, sometimes how data organizations unfortunately have been viewed. Like, I'm actually a profit center as the CDO. I'm making money off of our data, by offering valuable services or by monetizing it. Like, I think that's a cue for, okay, do I have the systems in place to do that at a level where I'm ready to be out in the market, where someone, my competitor is a click away to do the same thing. And part of my differentiation is my quality is better than theirs. My system is better than theirs. Like, I think that's another cue for, maybe you want this. And then I think the last bit is around, kind of the type of people that you're hiring and you're bringing on. I think for our new initiatives, we're trying to use more open source. Like, we're trying to write more code, take advantage of all the frameworks and libraries there, as well as like just version control. Like, I think that's another cue for like, I probably want a system that's going to let me instrument that code and those systems, like just as I would for normal software, and make sure they're performing well. So I think those are some of the traits that, we see as like, okay, this organization is probably, looking for something that can help them get reliability. I think we also see groups that it's like, they do have a use case of like, I'm trying to figure out like where my data is and what does this column mean and things like this. Like these classic lineage, cases, which are super valuable. Like that's, in our view, I would say, let you deal with these modern data pipelines and kind of the new use cases and new standards.
As you continue to work with the team at Acceldata and work with your customers and give feedback and direction to the engineers, what are some of the things you have planned for the near to medium term or any projects that you're excited to dig into?
Yeah. So I think one of the cues, for us basically is around like ease of use and user experience, which maybe sounds strange, maybe, but like I do think particularly in the data engineering world, like, sometimes I would say like speed and performance and scalability like are the first things, which they are for Acceldata as well, like in our product. But I think one of the cues I'm trying to introduce a little bit more is say like, let's stand out and like, let's try to make sure we're providing something that's just, people use the word delightful, but like, basically like delightful experience, right? And that doesn't mean it's a pretty chart or things like that, because that may not be what data engineers are looking for. It might be a really straightforward API, like a really easy way to instrument these, a really great set of automated rules and alerts and things like that. So I would say that's one, big aspect we look at, and I think in terms of exciting things, we're building now, like I do think there's a lot that can be done with, basically data science best practices and applied data science, like in the data world. Like that's the big advantage. There are advantages that the APM sort of vendors have and things like this, where they've been around for a long time. They worked on stuff. The big advantage of data, observability companies is we get to work with actual data sets. And so, there's techniques you can apply on those that you can't apply on software. And so we've got some nice ones cooking now and, should be exciting to roll out a little later this spring.
Are there any other aspects of the work that you're doing at Acceldata or the overall problem space of data observability and data monitoring that we didn't discuss yet that you'd like to cover before we close out the show?
I think maybe the cost aspect of some of this stuff. And I guess the observation we have is like, we meet with a lot of chief data officers and data executives and things like that. And we just see, kind of a somewhat starting to be alarming. Like there was a time when people were very excited about the potential and the ease of use of a lot of the cloud data processing technologies. And like for many companies, that time is still there. I think there's starting to be, just from our discussions with sort of data executives, there's starting to be a little bit of a note of kind of, worry or fear on things like this, where some of these costs really are ramping up pretty quickly. And in many cases, they're done for like small reasons. Like this connection was left open and that meant you use this type of engine instead of that type of engine. And that means, it turns out that engine this week was 3 times more expensive. So you burn through that. So I guess it's just an aspect that, we try to be mindful in our product and with our customers is like people basically looking at this and saying, hey, like this technology is all awesome. Like, I love this. Like, I don't have to wait for these things anymore, but how do I get a handle on the cost of these operations? And can you help me, optimize that? So that's an interesting, dimension, I think, for people to be thinking about these days. And I think one of the challenges embedded within that is basically like maybe some incentives that are not identical between kind of the vendor of the cloud data processing platform and the user of the data processing platform. I think cost is a lens. Like we can, have a lot of fun talking about the technology and the ways we work with these things. But I think, it's probably a good time for everyone involved in data engineering these days and using these new technologies to kind of take a fresh look at some of these things and understand how we're measuring costs, how we're monitoring costs, and how those are growing. Because my sense is that the back office teams are starting to get a little bit surprised by the bills that they're getting from some of these great things.
Yeah, that's why there's a whole industry now of companies built entirely for cloud cost optimization and being able to help you understand how to reduce your cloud bills. And it'll be interesting to see how that starts to leak into things like these cloud data warehouses and some of these other SaaS vendors.
Well, it's kind of the same thing. There's been a market, of course, for application monitoring and things like that and software monitoring. And now there's starting to be that for data observability. There's been this thing for Cloud Zero, like all these, cloud optimizations companies. Is there going to be that for data? And like, are these systems sufficiently complex and varied, such that you need, that expertise to understand how to do that? And like, I think my perspective is certainly yes. Like even just trying to master, 2 or 3 of the leading ones, like let alone get into the 23 different ways you can do streaming data analysis in the cloud. Like it's quite challenging. Actually, there are companies coming out that are built solely around even one of these technologies. Like, here's how you optimize, this type of spend. And of course, the vendors themselves have their own interest in this. So it's going to be an interesting area to look at. But I think, again, from the multidimensional data observability aspect, this is a lens that we think people can't really leave for someone else as much, because whatever analysis you're doing, whether what the cost was or not, it did have a potentially significant cost. And I guarantee that someone at your company is going to be looking at that a little more closely in the next few years.
Absolutely. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I don't know about data management, exactly. I'll just say the reason I joined Acceldata was because I was working, basically at the far end of the spectrum where you're relying on process data and you're doing awesome, very cool AI, things with it on top of it. It's very exciting. And obviously, many people in the data world are listening to these things and reading these posts around this awesome AI technology and things like that. And so I think the biggest problem is we don't have good enough data pipelines to actually make use of the machine learning technology that we've managed to do, all across the world in open source, Google, Microsoft, whatever. I think that stuff is incredibly cool. To actually apply that to most of the problems we have, we have to have better data pipelines. And so for me, I think we're able to move data very effectively. We're getting better at getting automated documentation and management for that. But I think the cost of that has been fragmentation. And so I think the thing we need is something that lets you, plug in all these technologies, and there's going to be more that evolve, plug them in and actually do this in a way where you can make sense of it, enough to actually depend on, run your business off of it. So once we have that, and it's not hey, these are 2 or 3 problems that we can apply ML to, or it's not, hey, only this big company, tech giant is able to do this. I think that's going to be the exciting piece, because then we're going to connect, kind of on the one hand, our raw assets, on the data side, and on the other hand, this amazing technology on the ML side, and actually be able to do that, for 100 use cases at every company instead of 1, 2, or in some cases 0.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at Acceldata. It's definitely a very interesting and constantly evolving problem domain. It's always great to see the different perspectives that folks have on how to approach data observability, data quality management, being able to optimize our data operations. So I appreciate all the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Thanks so much.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.